everyone, how are we doing? Oh, I need to get the Stats 1 banner back. We'll see if people join the chat. We'll get Mubot awake right here. Where did I put the Stats 1 stinger? That's what the thing is called. Changed it over yesterday because we're making some new stuff. Do I have it called Where did I put that? Let's find it. I hate that it does like by dates. I don't want it to do any dates on. I'm looking through my files right now. List. Okay, a long time ago, but that's now I want still the file size that's on here. That's the opening video. See that? And these are not sorted now, I don't think. Details. Oh, I wish it just showed me the... There's the size. Okay, so I'll just have to do this. Oh, there's Skeletor. I haven't done Skeletor in a long time. Oh, I think I see it. Stinger 1. This might be it. Is it? Find out. Wait, I can preview it. Where's the preview? Hey, I found it. Oh my gosh, I found my transition screen. What? Got a bunch of other ones I need to use again. There we go, found it. So to search my files. Okay, let's see. Let's do a little 320 right here. Search all the files. So we were able to fix something yesterday. We'll see if 320 watches this. 320, where you at? Maybe I'll message them here. Let's see. Okay, let's go here and say currently in office hours talking about 320. Oh, people are looking at the Disney thing. So at BS 320. Currently live on YouTube. Talking about the midterm. And let me post the link for people who want to join. See if we get some people in here. And then we'll timestamp this. There we go. There's that. And timestamp what we're doing right here for the future. Someone to come back and watch this later. So we are currently at 513 BS320 midterm. I'll talk kind of general about the midterm first. So the midterm is all about interpreting data. So when you think about interpreting data, you get lots of data when we do analysis right here. Probably some of our favorite functions. We have a really favorite one we use in reg class, the associate function. So the associate function can take any sort of X, any sort of Y combination, whether it's categorical, quantitative, whatever we want. And then we can take a look at the association between the two variables. So knowing the output here is very important, such as if we take the data iris. Oh, there's the iris data set. It says it promises it's there. If you run that again, you can actually have it appear. We can take a look what's going on. It's a really good function that we don't use nearly enough that we should probably use called glimpse. Glimpse right here gives you a glimpse of the data set and it augments to the screen. Well, in this instance, it augments, but then it could get smaller if you have it smaller. So it's not going to do it right there, but when I rerun it, it's only going to go to the screen. So you can see what's going on right here. Species is a factor, which is a categorical variable. It's kind of similar to doing this right here. But this is a good way to just kind of preview what you have. And you can see there's 150 rows. Hey, Millen, good to see you here. Talking about glimpse for a second, which is a good function we rarely use. But you really should kind of, when you get a data set, start looking at it. And this actually goes to one of the problems that was created with the data we had. If I had looked at it, I might have noticed this. The game's data frame right here has a problem. This was the whole problem with the merge. When I was trying to left merge and I was like, this should work. What's going on? This should work. This one observation right here is the problem. So if you notice, it has no other data with it and it just has a date. That's the only thing it has. So that shouldn't exist. But the problem is we're merging on ID. And the ID right here, 1 also merges in. That was what was causing the error. Yep. And I should have noticed it. So here, I'll show you what happens if we don't remove it. Here, we'll go to this line right here. And then let's do the merge right here and go to complete. So what's happening is if you look at this and you start scrolling down, we'll go all the way to the right, you start to see this nonsense right here. And this is where game ID 1 starts. You get all these NAs right here because it's merging on game ID. And does it keep doing it? It just causes a lot of problems because game ID should be like unique for everything. And when it merges in, it causes a problem because there's 2 game IDs and it might just break it from there out. So the big problem is this game ID right here, game ID 1, is also all the way down here at the bottom. So to fix this, all I did was go over here and say, delete that last row. So if you watch the data frame over there on the right, the games, where it has 1001 rows, I went in and said everything but row 1001. That deletes off that row. Probably won't run again because we don't have that row. It just doesn't do anything now. And then when we run this here and do complete, it has the same number of rows. And now if you take a look at complete here, you get the following. And it seems to run up. It's a little weird again. That's fine. It's now working. There's missing stuff some places, but everything seems to be working. And now we have the names of the games. So you can see the name of the game right there. It's Minecraft Java Edition. There's a lot of cool stuff. Well, it could have saved me some time. Oh, no worries, Josh, right there. That's just... Oh, but I posted it on the Discord too. Did you see I tagged the message on Discord? It's a little higher on the code. If you go over in the code, it's just a little bit higher where I have the pinned message here. I pinned Thomas in it, but then did I tag anyone else? I think I pinned it. There was an extra row in games, and I said that right there on the Discord. So I try to announce it on Discord. Always look at the pinned messages on Discord. I've been pinning the messages for the week on the Discord. No worries. Yeah, this is totally recorded. Everything's always recorded, Millen. Everything's recorded. So when you're doing this right here, you can run. You got to be careful, though, because you have to think, if I just run a code, it could come out a mess. And if you were to look at something like associate, and you just got to be careful here. Oh, no worries, Bella. Don't worry. That's why I do these things too. But ask questions if you got them. Yeah, prepare for the exam. Prepare for some exams. Good luck, Millen. If we go to the complete data set right here, and once again, it's all what you want to do. This midterm is just what you want. So that's what we're going to do, is we're going to do something we want. Maybe we want to look at, this is where you got to be careful, is platforms has way too many what's now. If you look at, hey, let's go see here. If you see platform that the game is on, and frankly, let's go to complete. It might have, let's go platforms. Look at that. So the way they're doing platforms right here is I might actually be able to repair this variable. So the way they collected data on this is platforms is a what? If you look, so it's got levels, right? It's got too many levels. And if you look at that variable right now, it's telling you what this game is on. Does that make sense? I believe that's what it's displaying to us right here. Like that game right there, whatever that is available on PC, Android, iOS, and web. Are we going to see something else? Here, let's go to levels of it. Let's take the variable and go to levels. And there we go. Okay. So this right here means that these games are what? What's up, Sloan? Yeah, let's do some practice on it next. You got it, Sloan. We'll do, let me set a, I don't want to do 30 minutes. We'll do about 2 10-minute timers. 20 minutes from now. So if you come back in 20 minutes, we'll be doing it. So what does that mean? 464, those games are what? Like, what does that mean, Xbox PC, when we see platforms? Should we be, so yeah, that's what we're going to have to do. So this is going to be a little bit of fun here, Josh. These are the things that, like I would think we could do. We can definitely do it. See, the thing is sometimes these things are easier in Excel. Like sometimes there's a really quick way to do it in Excel, because we need to separate. Let me do that. So let me look up a code. You ready? Separate column. No, here's the problem. Okay, I know what we need to do now. So the problem is it's not always in the same order. Does that make sense? The problem is it's not always in the same order. So we need to run a totally different code right here. The totally different code we need to do is we need to search this and see if it says like Wii or let's say PlayStation, Xbox One. We're going to look for Xbox One games. And to find Xbox One games, we need the following code. We're going to go to grep, and grep searches for a pattern within a string. So these are all strings because they're words. So pattern matching right here. You can do replacement and stuff like that, but we're not going to do replacement. But what we're going to do is we're going to go to grep, and we're going to grep, look for, I guess it's greplace. We're going to look for this pattern right here within the string complete, $, and platform. Now this returns to the positions where that pattern exists. So here's the thing. These are the rows where it is true that that game is on the Xbox One. So these are games that are on Xbox One because in the platforms it exists, this right here. So now what we need to do is we need to take and we need to say if else 1 through n row complete equals no is contained in. I don't want to do equals. I'll do pattern match. Then say Xbox on Xbox One. Yeah, sure. And then else not on Xbox. There we go. And we could call this on Xbox One. Oh man, such a long code. Should get the vector. There we go. And then a factor of that. There's the factor version. And then we go here to complete. And then we say complete on Xbox One. And there we go. There's the code. And any other game system could be done the same way. Make it look a little prettier here with this. But does that make sense? We could do this for any game system we want, where we could check to see if the pattern is there within the platform. So all we're doing is we're seeing if the row right here, is this row number contained over here? Yeah, that makes sense. Because it would see the first one is not, so yeah, that makes sense. Just making sure I have it in the right order. We could also double check. We might want to do some checks to look at the games. So we could go to here and go to unique, or let's do the following. Let's go to complete. And let's go to filter on Xbox One equals. And we could have done here yes, no. Let's do that instead. Yes, no. And there we go. Equals yes. That's good. And Xbox One only. Okay, so these are games that are only on Xbox One. So I'm going to go to unique, Xbox One only, $, and name. And these are games, they must be on Xbox One. You could pick a few, and that's what you could do right there. You could pick a few games right there to look at this. And yeah, like DuckTales Remastered's on it. So you might want to look at Disney, Aladdin, Genesis, because apparently that's on Xbox One, but there's a lot of virtual console stuff. These Rise of Tomb Raider, yeah, that's a Xbox exclusive right there. It's not on PlayStation. A lot of them I'm seeing here make sense. I don't want to see something like Super Mario World, Metal Gear, of course, Red Dead, Mega Man 6. You have Mega Man X6, not Mega Man 6. Yeah, Mega Man 6 wouldn't be on it. Mortal Kombat 2. So you might want to look to see like if Mortal Kombat 2 is on Xbox. But all these look like Dark Souls classic. Super Meat Boy Forever, the new Super Meat Boy, the runner, constant runner. It looks Enter the Gungeon. Heck yeah. So this looks accurate. Does that make sense, Josh? Like it looks like we found only Xbox One games. But you want to pick things that speak to you, because you could just easily change this right here and go to on Switch. And so we're just going to take right here and grep switch. So now we're going to look for switch right here. And then we're going to go to the complete and store it right there. And then we could take complete and filter switch to say switch only. This should work right here. Let's see if it does it. Is that on the switch? Store the variable right here. Switch not found. Factor of switch. Oh, yeah, because we were doing on switch. There we go. And then complete filter switch equals this. Switch only. And these are on switch games, we should say. Can you do a chapter? Yeah, which one you're wondering about? Let me know, Isabella. We can do that here. And unique. Oh, we did unique Xbox One again. Let me go to the other one real quick. We need to go to unique Switch only. And these are games that are on Switch only, which now we see things like Super Mario. So we should see more of the Mario games, Bayonetta, but it doesn't mean they're only on Switch. Yeah. Aw, thank you so much, Sloan, right there. I appreciate that. You bet. Here, let me mark that in the notes. And then we're doing Canvas content here. We got about another 10 minutes on this, and we're going to do Canvas content. So, Isabella, you got it. Sloan, I really appreciate that. Canvas content. Did you say number 6, Sloan? Which one did you say? Canvas content. Number 6. All right, cool. We got both those things marked right there. So this is pretty good code, helping us just find things on the Switch right there. Put it in the Discord. There we go. Code for finding games on a system. Yep. There we go. That's the code for finding games on a system. Just looking for if it's on a system. I'm trying to think what else. Well, another thing that we can do is we can do variable creation. So when you think about it, and we've done a lot of this, and we're already doing it right here. We're already creating a variable right here. We already left joined it, right, to complete. This should go after. I want to keep my work in order. So, I was doing N64 games, right? Complete grep. What's I doing right there? Grep. I don't know. Doing a lot of different things. Okay, let's grab this code, put this after we do this right here. Well, you know what we could do is we could compare two groups. Well, some games are on Xbox and some games are, let me look at my complete data set now, because we should have, like over here, so we might have games that are only on Xbox and only have Switch. So we can figure out if a game is on both or on neither. So we would want to look at this and say, like, if it is on Switch and not on Xbox, we could say, like, it'd be interesting. I don't know. Lots of ways to do this, and we could compare games that are on the Switch versus games that are not on the Switch. But the thing is like these groups overlap because sometimes a game is on Xbox and on the Switch, like these games right here. So game that's on both is, where's the name? Celeste. Yeah, that's a good game. So 2018, man, good game. So that right there is the game that's on both consoles. And yeah, it'd be actually interesting to see like which consoles have the most runs. Like, where are people running the most games? Like, if it's on the Switch, does that really increase it? So you could go to Associate, and we could look at in here. We could say if it's on the Switch. Don't just do my analysis. I should stop doing analysis right here. I'm not going to really analyze it much. I just want to see this. And let's look for the total runs. I am interested. Oh, one more 10-minute timer, and then we're going to do the thing here. Total runs. And then data equals, and then complete. Okay. Yes, I want to run it. That's why I asked you to. Let me make the output bigger. So we're going to see side-by-side box plots here because we're analyzing the difference between games that are on the Switch and not on the Switch and the total amount of runs they have. So we must compare medians right here. The data is heavily skewed. The QQ plots for normality are insane. We're still generating the output for the medians and the permutation procedure down below. That's what's taking the longest time is all the random permutations. 500 random permutations are being completed for 3 different tests. So it's running 3 different instances of 500 random permutations. And there we go. The output should appear, and all of it is statistically significant. You're welcome, Josh. So this is all very, very statistically significant. And you know, it's crazy. So this is the thing. Games on the Switch have a lot less runs. So the Switch is a lot less competitive. That's like my first takeaway right here. When you compare games on the Switch versus not on the Switch, can you explain what runs means for a game? Like the conceptual? Yeah. And the big thing, and thank you, Bella, for asking right there. Here, let's pull this up. Is for this data set, and definitely, I'm so glad we had Cosmic come by. Huge shout outs to him right there. But for the runs, definitely go here. So I'll put this in the link. And it's like how many times people have submitted runs for this game. So a run, like Cosmic did a run for us where he was running the game, because we're looking at num runs, right? Oh, this is the other data set. Let's go to this one, and we're gonna get everything selected right here. And what's really great is for this, so we got everything selected, and now we go to number of runs, and it gives you a little interpretation of it. Total number of runs registered on the leaderboard. So that is how many times people have entered a run that they are submitting for the game. So that's the total number of runs registered on this leaderboard. And so it's kind of a measure of competitiveness. If there's more runs, like it's how many people have like said, "Hey, I want to be the best." Does that make sense, Bella? So here, I'll show you what this. We should have showed this too, probably. So here is Cosmic's runs. So this is Cosmic right there. He's got his location over there, but that's fine. So here's all of his places. Like he's first place on Battletoads. Why did I not talk to him about Battletoads, the Japanese version? I should have, man. Wow. Oh, he did co-op? That's insane. Wow. Anyways. Super Mario Bros. 2, all these things right here. These are all his runs he's submitted. Does that make sense? Like you can see all his different places, like 3rd place, 23rd, 6th. You get the really nice medal over here when you get the higher things. So all these different games, like first place, my teacher is an alien. He's a little Mario 64, like doesn't have the high competitive times there, but 3D Land. So first place, Space Chimps right there. Luigi's Mansion. So runs are submissions. Exactly, Bella, you got it. And that's the kind of things. Ask those questions, let me know. And if you look at his first place times right here, the lost levels. What's really cool about this is you can actually click it and watch his speed run. So here's Cosmic right there playing. He might have the date. I wish he had the date on here. Does he? He might somewhere. But they track like the amount of runs they do, and he probably is going to get hit. I bet he gets hit. Ready for it? He's going to be like, boop. Or he might be, there he goes. So he's probably just practicing right here. Usually they show a little bit before they reset. And then he goes through here and plays the whole game, and they've got their splits. They actually do things like getting a gold split. A gold split is like their best time ever. The green means they're ahead on time, so they can kind of track what they're doing and see like where they're at. And they just love doing things like shooting fireballs. Like, oh wait, Cosmic, don't hit me with a copyright claim here. We're talking about your stuff. You might see that we are watching his video right here. Problem is, I could just watch the whole thing. I could just sit here and watch. Look at that. He's just, yeah. I don't know if that's a skip or those springs are so weird. So they do some weird mechanics. And he's just going to jump over Bowser right here. Or he's probably going to fireball him. And then it takes less animation because you don't drop the bridge. I know too much about these games. We all know too much. But with this right here, you can see his time ahead of it and where he's at. So that's kind of what you want to do is you want to be looking at, well, we're getting a ton of advertisements, so let's go away. But it's really cool. Like checking this out, seeing what games people are playing. Roblox apparently is super popular. Celeste is also super popular. It's probably one of my favorite games right here. We'll switch topics here soon, but these are all the runs on the leaderboard. And what's really great, once again, if you want to see some crazy speed runs, this game right here, the things people do in this game is nuts. It's a platformer game. And so it's all about precise movements and not hitting the spikes. And the ability, like, that's just amazing right there. I beat this game, but the level of abilities people have right here, like just going through the platforms and stuff, is nuts. And I don't know if they did like every level, but if we went to like the 100% of the whole game, it'd be pretty crazy. Oh, such a cool level. And they just make it look so easy. They're just like, yep, just jump around here, do this, this, this. And this is probably one of the most beautiful games I've ever played too. Like the storyline, you'd think, how could this game have a storyline? Go check out the game. Anyways, tons of advertisements on this page. So that's what we're analyzing right here, trying to figure out what is more competitive, what is not competitive. So once again, Cosmic came and spoke to us to talk about kind of the meaning of the data. Remember, don't present your findings to people like this. This is basically for us. We're going to clean this up and make this look nicer. So don't just hit someone with all this right here. Like, you don't want to just be like, aha, here's my findings. I'm just going to take all this and drop this into the report. No one's going to have any idea what you're talking about here. Also, the graphics don't look as nice. We can easily make this graphic over here look way better. To do that, we are just going to look at kind of the basis of our code right here with the total runs and the switch. Now we're going to go over here to library, ggpubr for publishing our graphics. And we're going to go here to ggboxplot. In ggboxplot, we need the data, the x, and the y. But once again, I usually like to take these and use the help function to get something basic that looks kind of nice. And you see they already have some of the format down here, and it looks like it's a two-group thing. And they've got the color equal to the sup. Maybe we won't use that one because that looks more variables. Fill equals dose. Okay, here we go. Let's grab this one right here. Ooh, I see this one right here looks a little nicer. Okay, I think I use this one all the time when I use it. Okay, and even shows you, these are hexadecimal color codes. If you want UT orange is FF8200, and that is UT orange. So it shows you that right there. You can kind of play with it. This is the amount of red, so we can tone down the red. This is the amount of green, so you can bring up the green. And then this is the amount of blue. So this is basically all green right here. This is red-green. This is just red. And this is red-blue, so we'll get purple. But it's fun. You can play with it. You need the hashtag, and it'll show you the color code. Or you can just simply write things like purple. I wish it showed you purple right there, but it doesn't. So it's more fun to play with the hexadecimal color codes. Purple? Purple. Whoa, it does show purple. Oh, it's so nice now. Okay, so we got some colors, but we only need two. There's our two colors. We need the data frame we're using, which is the complete data. We need, I think it goes the order of XY, is it? It's XY, so on the X-axis will be on the switch. That will be in quotes right there. And then the len is the Y variable. And then dose, I think, was their X. So this goes here. And then the shape, let's try that. Does it like it? Looks like it likes it. It's a bigger data set, so it takes a little bit of a moment to generate the graphic. And we automatically see an issue. We do not want the points right there. So we probably want to remove the jitter. The jitter makes the points kind of go, because points will overlap if you don't jitter them. There's a lot of data right there. So the jitter is actually a not good thing in this instance. This is where each graphic is kind of unique in how we make it. The shape, pretty good. Well, there we go. And I think we can go here and go to legend and go to right. Yeah, there we go. There's the legend on the right. And as we usually do, we try to make this look a little bit nicer. So we go here to labs. Is it labs? It's labs. And then we go to X equals on Nintendo Switch. And probably don't want to regenerate this every time. There we go. Y equals total number of runs. There we go. Regenerate it. Why not? Make sure it works. And then the title equals comparison of runs on Switch to not on. Or runs or total runs versus not on Switch. I could play with that title a little bit right there. Yeah. Run comparison. Comparison of, or competitive. Is the Switch competitive? Whatever you want it to be. And then last but not least, we're going to start up another library right here. GG easy. And throw on some easy center title. There we go. Easy center title. And then let's try one last thing. Before we do the easy center title, let's go to library, GG themes, and go to theme. There's the GG themes. There's some advanced themes I think you can get. Well, there's the GG themes. So you can do whatever you want right here. The themes just give you a different look, and you can just try different themes. Make sure they're from the GG themes, though, or ggplot2 themes. I think this one looks pretty good a lot of times. Missing the lines. Not bad. It's all about what you want, though. So think about, you're just making this look the way you want it. I think this one I don't like, but oof, look at that size of that title. So now we need to fix this with an easy all text size and put it to 12, and that might fix it. Actually, you know what? Not that bad. Not that bad once we fix... not that bad. I mean, I don't know. Looks like it could be in an online publication or something. So, you know, this is what we're going for. It's all about what you want, how you think it's going to look nice and neat. Yeah, how does this show if the switch is competitor or not? They had similar numbers of runs. Do they, though? Do they have a similar number of runs? So what should we compare between these groups? So let's look back at the code over here. And very clearly, I got to wait for this to run again. Very clearly, we should be comparing the what's between the groups, Sam, and then we're going to switch topics right here. Very clearly, we should be comparing the what's between the groups. This goes to the midterm and the analysis. Like, this is we have to compare these between the groups. The medians. Boom, right here, the QQ plots. You can also see it over here. But we look at the QQ plots. Don't look at the histograms. It's better to look at the QQ plots. Very evident. So when you look at the medians, think about this. Like, take a look right here. What do you notice about the amount of runs for things that are not on the switch versus things that are on the switch? What do you notice very clearly? Things not on the switch, what? And these are runs submitted. What do you notice? More than twice, right? It's if you do a ratio right here, so you could, that'd be a good thing to report to somebody. I hope I don't want to do too much analysis, because once again, I don't want everyone to do the same analysis I do. Don't just do, I'm just showing you examples. There's over 136% more runs for things that are not on the switch. You could also look at the amount of platforms something is on. Like, there's a lot of ways to do this, but yeah, definitely rough quick math right there. So the goal is that, you know, you think of things to analyze. Like, I'm just thinking of things right here that I could look at and then write about in my report. So I could, you know, think about what you like, what you want, what you would find interesting, what Cosmic said he'd find interesting. And then your goal is to then analyze and create this. So you're not meant to copy all the code I do, but you're meant to, remember, like, we did GG box plots. So if you think about, like, we made these graphics earlier, you're basically just using everything you've done in the class right now to make a report. Does that make sense, Sam, right there? I'll start the stats 1 here. But you're using all the knowledge you have to then write a report that goes over the things we've learned. So it's not to, like, just copy what I do. It's like, okay, I need to write a report that goes over the things that we've been covering. So the better your report is on what we've been covering, the better you do. Like, if you bring in things that we've done and show the techniques, that's great. But you don't want to just be like, oh, I made a graphic. You want to be like, here's what I'm investigating. Here's what I saw. Here's what I'm learning from this. Because that's the point. It's just to learn from data. Learn from data. Canvas content number 6. We've done a lot of versions of this. Yeah, great job right there, Sam, in the chat. Canvas content number 6. Stat 201. Canvas content number 6. Let's go do it. Okay, we got some Canvas content number 6 right here. So we're going to go over this step by step. Remember, the goal is to learn the concepts. So remember, I'll usually quiz you on things that go beyond the question. Let's go ahead and preview this right here and take a look at what it says. Preview. Okay. When thinking about what happens with combinations of outcomes, events, so that's like flipping a coin twice and getting 2 heads in a row, that's an event. Things are simplified if the individual trials are independent, like flipping a coin. Roughly speaking, this means that the outcome of one trial influences or changes the outcome of another trial. So this is very clearly true or false. Very clearly. So this could be summarized as independent means 2 things influence each other, like trials influence each other. The summary of this question would be independent means. Summary of this means, yeah, they do not. Independent means trials influence each other. And that's the summary of it, and that is very clearly false. So when you think about independent, we have a way of checking, and I think I try to teach it perfect. The example in the first class works so well. Thank you to RotoWave. RotoWave was talking about like games like Apex, so we use that in the next class, and I think those work really well. So when we talk about independent, if A happens, does it influence the probability of B happening? If yes, they are dependent to some degree. If no, they are independent. I like to use the example of if your parents say to you, we are going to get you a cat or a dog, but not both of them, would getting a cat influence getting a dog? So if I get a cat, does it influence the probability of me getting a dog? Well, if your parents are only going to get you one of them, then getting a cat would make it so you can't get a dog. So getting a dog would depend on getting a cat. So use this wording right here for independent. If A happens, does it influence the probability of B? If yes, they're dependent. If no, they're independent. The other word people usually get mixed up with this is the idea of mutually exclusive. The idea of mutually exclusive can be summed up: if A occurs, can B occur? If yes, they're not mutually exclusive. If no, they are mutually exclusive. So I'm using the cat-dog example here again with the same parents, where they say you can only get a cat or a dog. So if I get a cat, can I get a dog? This is not the same thing as independent we just did earlier. Because you'll notice, if your parents are only allowing you to get one, if I get a cat, can I get a dog? No. Getting a cat and a dog are thus mutually exclusive, which means getting a cat also would depend on getting a dog. Now, that's bringing back the previous topic, but make sure to ask the questions this way. So please, I beg of you, write this down, because a lot of people get confused on mutually exclusive, which is the same thing as disjoint. That's why the circles don't overlap. They're disjoint. They exclude each other. But a lot of people confuse mutually exclusive disjoint with independent dependent. They're like, well, aren't they the same thing? Well, things can be dependent and not be disjoint. Like you could say, snowing outside depends on the temperature. So could it be 40 degrees and snowing outside? I guess technically, right? So you could say it could be 40 degrees and snowing. I mean, the snow might not stick and it'd probably melt really quickly because it's above freezing. Like the atmosphere up above might be cold enough for snow. So you might say there are instances where things are dependent, but not mutually exclusive. Like you could say your grade on the test depends on if you study. So getting a good grade depends on studying, but someone might not study and get a good grade. So it's not like you have to study to get a good grade, which is going to be if you don't study, you can't get a good grade. Like then saying they're, disjoint. Like people who don't study can't get a good grade. But we could say, future career. We could say getting a good grade depends on studying. So there's a lot of ways to think about these questions and to understand that these are different topics. But it is true that things are disjoint are 100% dependent because it changes the probability of the other event to 0. Because if your parents say you can only get a cat or a dog, then if you get a cat, the probability of dog goes to 0. So in the instance of disjoint, things are 100% dependent. But if things are dependent, it doesn't mean they're disjoint. So let me review what I just said right there. How the two pair. Things that are disjoint are 100% dependent. This is because if A happens, the probability of B becomes 0. Things that are dependent don't have to be disjoint. This is because, like we could say, I'm trying to think of a really good example right here. Like if I were to say studying the day before the test and failing the test. Okay. So when you study the day before the test, does this influence you failing the test? And that's the test we have for independent. Let me delete all the slides between all these, because we won't need them. So if you want to see if they're independent or dependent, we go to our test right here. And here's the test. Oop. So if I study the day before the test, does this influence me failing the test? Yes, because you're less likely to fail. If I study the day before the test, does this influence the probability of me failing the test? So we would say yes. But if I study the day before the test, could I still fail the test? If I study before the day before the test, could I still fail the test? Yes. So they're not mutually exclusive. But in the other instance, we could have here, if your parents say, or we'll do the other example, if it is 90 degrees, or a probability of being 90 degrees and snowing. Okay. So now we have the two events right here, 90 degrees and snowing. So we ask the independent one first. If it is 90 degrees, does this influence the probability of it snowing? Yes, they are very dependent. Now we ask the mutually exclusive one. If it is 90 degrees, can it be snowing? No, there's no way if it's 90 degrees that it could be snowing. The snow wouldn't make it to the ground. You can't say, well, what if the atmosphere is like 20 degrees? Well, the snow wouldn't make it to the ground. It wouldn't snow. Well before it gets to the ground, it would turn into rain again. So there's no way that it could be 90 degrees and snowing. So that makes it disjoint. And I think a lot of people get very confused on these two ideas of independent, where if A happens, does it influence the probability of B? Or disjoint, which is also known as mutually exclusive. If A occurs, can B occur? And these are the best ways to check it. So take these notes right here. Those are the shorthand ways of knowing if it occurs or not. And then these are the things that are independent don't have to be disjoint. Things that are disjoint are 100% dependent. So it works that way. Really good question right there. Once again, understanding what the word independent means, and this is false. False right there. The probability of a new marketing campaign being successful given the past history is about 30%. The company is rolling out 5 new campaigns. What is the probability at least one is successful? These are some of the hardest questions on the test right here, and we'll break it down into its parts. So when we look at this sort of question right here, we have success is going to be 30%, and not success is going to be, I think Sloan's already done it. Sloan 100 points right there. Not success is 70%. So if you look at what Sloan's written, we'll look at the equation. It's 1 minus 0.7 to the 5th power. Let's talk about what 0.7 to the 5th power is. Well, when you have these 5 marketing campaigns, what would you not like? So I'm going to do a little color coding here. What would you not like, Sloan, when you have these 5 marketing campaigns? When you have these 5 marketing campaigns, you would really not like what? What would you not like to see? So we did a little color coding right there to help with the example. What would you not like? How about that, right? All the marketing campaigns are not a success, right? So every one of them, all 5 are not successful. But either all 5 will not be successful or at least one will be successful. So either, and think about this with like classes, either you'll fail all your classes or you'll pass at least one. And these are complements right here because they give everything possible, and complements add up to 1. Because one of these things must occur. Either we're going to lose all the marketing campaigns or we'll be successful with at least one. So what Sloan is finding right here with the 0.75 to the 5th power is all not successful. Because when we say this, it's that the first was a failure, the second, the third, and the fourth. And this is assuming that each marketing campaign is independent of the previous marketing campaign. That's a big assumption right there. If the question asks, what assumptions did you make? We would have to say, to multiply them together, we would assume that each marketing campaign is independent of a previous marketing campaign, and this mathematically equals to 0.7 to the 5th power. This 0.7 repeatedly times itself. Now that we know that it's 0.7 to the 5th power, we can see here that we're adding on at least one success, and this is equal to 1. Well, now we do a little bit of algebra right here. And with a little bit of algebra, we bring this over to the other side. Oop, not that. I don't want that on the other side. Bring this over to the other side right here. And we do 1 minus it. And there's the answer. And that's what Sloan gave. So it really boils down to we are trying to solve what's the probability of at least one being a success. And then we know that either they will all be failures or at least one will be a success. and then we can solve the equation right here for the probability of at least one success is everything, because one is everything, except all failures. So that's how that would read at the bottom is everything except all 5 campaigns are failures would be at least one is a success. These problems take a good bit of practice to do. We did a little bit quickly, but the more you do of them, the better you get. And try writing it down right here to see what it looks like to say, well, I don't want to see all failures, so I would find the complement of that. Also, writing out longhand helps there too. One of the harder questions, and when we solve this out right here, we go 0.7 and times 2, 3, 4, 5, 1 minus that. And there it is right there. Boop. Suppose event A is taking 15 or more minutes to get to work, and event B is taking less than 15 minutes to get to work. Are events A and B complements? So when you think about this, and we're not trying to be too tricky right here, we have that either you take 15 or more minutes, so got right here, 15 plus, and then we got less than 15. So given that you got to work today, it should say that. It should say, given you got to work, it either took you 15 or more minutes or less than 15. This sounds like what right here, which we just talked about complements. So either it takes you more than 15 or less than 15, 15 or more or less than 15. With this right here, these are complements because it's everything that could occur. It's going to take you either 15 or more minutes or less than 15 minutes to get to work today, and that is everything that could occur, and thus they are complements because it's everything that could occur. This one right here shows you some wheels on a slot machine right there. So when we go to the wheels on the slot machine, they're going to look the following way. And we've got symbols on them. We've got skulls, lemons, cherries, and bells. And it wants the probability of getting a lemon, cherry, and bell in a row. So we're supposed to get the lemon, cherry, and bell like a lemon right here, a cherry, and then a bell. Not so much on any particular order, but a lemon, a cherry, and then a bell in that order right there. So you have to think, what's the probability on the first wheel that you get a lemon? Well, lemon occurs 3 out of 10 times, and we're just going to go here and do 3 out of 10. So 3 out of 10 for the lemon. The cherry occurs 2 out of 10 times, and the bell occurs 1 out of 10 times using the table up above. So there's the answers on those, and we're doing it out of the 10 total. Now that we know this, we would think the wheels spin independently of each other, and it does say that each wheel spin is independent of the other 2 wheels. So now we would multiply these together, and we would have the probability of a lemon, a cherry, and a bell. And that is going to be 0.3 times 0.2 times 0.1, and there's the answer. Ooh, not do that right. 0.3 times 0.2 times 0.1. There we go. Got the answer. Good to go. Done. Suppose the probability of a bus arriving on time is 0.52. Now, this one's interesting. It does say assume that each stop is independent. And once again, we need to know that when we do this, we're assuming that we can multiply. Or, well, we're saying we can multiply by doing that. So let's go right here and grab the data, bring it over here, and drop it in. So what is the probability that it's on time for at least one stop? This one goes back to the idea that we want to look to see at what we don't want. We don't want the bus is late to all stops, because that'll happen, or on time at least once. What if you did 0.6 to the 10th power for that last question? Would that be wrong? That would be, for the last one, 0.6 to the 10th power. 0.6 is the probability of, for the last one. That would be not getting a skull 10 times in a row. So that would be wrong. Also, 0.6 to the 10th power is a very, very small number. If that is the answer, but by luck. But that is by luck, though. That is just pure luck. That is not the right way to solve it. Because the right answer is 0.006, but that's just by luck there, Sloan. That's pretty interesting. It goes to that, but that is just by luck, though. Pure luck right there. The mathematics down here at the bottom. But thanks for asking. Jesse, good to see you here. And the bus is late to all stops, or it's on time at least once. One of these things must occur right here. writing this sentence is the key to solving these problems, that the bus will be late to all the stops, or it'll be on time at least once. And with this right here, the bus is late to all stops is going to be the complement. That is probability of late. So we go here to 0.48, and we have for the next 3 stops. It's probability it's late to all the stops. And there we go. There we go. And we're just solving for this right here. The key to these problems is being able to write this sentence and think through it logically. That the bus is either late to all the stops or it's on time at least once. So when you write this sentence, then you need to think about what the mathematics is. For the bus to be late to all the stops, it would have to be late and then late and then late, which is late 3 times in a row. So that's going to be the mathematics of 0.48 times itself 3 times, which is raised to the 3rd power. On time at least once is now just solved for by solving it over to the other side right here. And that's how we do it. There we go. And there we go. Let's take that problem right here. Okay. And then report to 3 decimals. Should have it. Should be good on it. Associate, number of runs, category. Yeah. That could do it right there. That sounds like some good analysis, Josh. Back here in one moment. Gonna grab some real quick. Be right back here, everyone. One moment. Which area are you getting, Josh? Send me the code you're running in the area you're getting. I can take a look. Let's take a look. We got one more question here. For BS320, I was wondering if there's practice tests listed in the modules. We could going over all the output. Your assignments are going to be the number one thing. The assignments are the number one thing. All the output in the assignments are going to be the number one thing. Interpreting output, interpreting slope, interpreting coefficients, number one thing. So like knowing how to explain it to people. So it's literally, I would say, understanding your assignments and the goal of each assignment. So the output for the test is literally just the output you would get from like associate. You write me back. Yeah. Oh, thank you, Sloan, right there. Number runs. Oh, because there's too few levels. You want to filter the categories down. You want to filter the categories down. You might need to send me it, but it sounds like there's too many categories. So you want to filter the categories down. Because some of the categories don't have levels, it sounds like. So you'd want to filter it down. The fun of working with real data. Real data has a bunch of issues, and so that can run to problems. The accompanying plot and regression. Let's go find it. Accompanying plot and regression. Where are we at time-wise? 56. Okay, the accompanying plot and regression. This is too small. There we go, better. There we go. The accompanying plot and regression shows some treasury bills after 3 months. So we got plot. After keeping track of his, yeah, we're doing next, and we'll probably end with that. Chapter 8 quizzes. Woo! Okay, so this one right here first asks us about the correlation. Oh, so it gives us the R squared. Is the correlation going to be positive or negative, Jesse? Is the correlation going to be positive or negative? So will the correlation here be positive or negative? Thoughts on that? Will the correlation here be positive or negative? It's definitely positive because the line goes up. So when we square root R squared is usually reported as a decimal. Like it's given to us as a decimal, reported as a percentage. So you have to turn this back into a decimal, square root it, and there we go right there. It's positive, and it wants to 2 decimals only. Sure, why not? Interpret the slope and the intercept. So the slope and the intercept, I think, are also given right here. There's the coefficient of the intercept, which is 0.61. Does it want to 2 decimals? 2 decimals. So at about starting at this. So the starting was the intercept. The intercept is where it starts at. And then the slope, which is 0.25, is for each additional year. So for each additional year, we expect it to increase by this amount. And the starting year, 1950, because I think that's where it starts. Or, yep, it's years since 1950 for each additional year. What does the model predict for 2029? Now, for this, we need to write out the model. So we're abbreviating it, but how are we going to write out the model right here? We need to take the y variable, and let's plug in to the equation. So rate predicted is what we're doing, is equal to 0.61 plus 0.25 times the years since 1950. And so all we're going to do right here, it's at 2029, is plug in 79. The reason we're plugging in 79 is because that's, is that correct? Because 2029 is 79 years since 1950. Oh my gosh. So 79 times 0.25, add that on to 0.61, and there's the predicted amount right there. So once again, you have to write out the equation using the values they give you, predicted rate equal to intercept plus slope times x variable. Plug in the value of the x right here, which is 79 because it's that many years since 1950, and get the percent right there. Would you expect this to be accurate? No, it's an extrapolation well beyond the model. So right there, the word extrapolation means we're going well outside of the x range of the data, and very important right there. And so really good problem. Shows you the intercept, the slope, talks about extrapolation. There's some plot thickening with this data too. It's really thin down here, gets thicker as you go across. So some issues right there. Really, really great problem. Like sometimes, I'm mean to my Pearson, but we pick the problems for a reason. Some have good parts, but this one really walks through some decent slope and intercept interpretations, finding R from R squared, making predictions using the regression model, and understanding what extrapolation is. Make sure to always look for what the concepts are in these problems and what you're meant to be learning, which is the key to acing the tests. Next question after keeping track, and this will be the last one right here. After keeping track. Start 201, chapter 8 quiz. After keeping track. Take a look at it. That one. We'll be doing that one, I'm sure. After keeping track. I just saw it. Oh my gosh. What do you instantaneously see, Jesse? If they don't get into this with this problem, that's a residual plot. But what do you instantaneously see that the residual plot has a what? Like that's like, there's 2 issues with this, but one's more obvious. A residual plot is the line set to 0 and shows you all the residuals. Curve pattern, yeah. Very quickly we see that here. Interpret the slope of the regression in context. So we're predicting somebody's cost of their heating their apartment based on the temperature. So the predicted cost, the model predicts a cost. Wait, it says slope first. The slope would be for each additional increase in temperature unit, since Celsius, Fahrenheit, Kelvin. We would expect the cost of heating. Hey, what's up, Philip? Great to see you here. 100 points, and to Jesse and everyone else. For each additional increase in temperature, we expect the cost of heating to decrease by this amount. So the model predicts a 1.81 decrease in heating costs for each additional degree in temperature. It even mentions that giving a 1% in 1 degree increase in temperature. So it kind of puts it in parts, like for each additional degree increase in temperature, the model predicts that heating costs will decrease by this amount. Interpret the y-intercept. This is the predicted heating cost when temperature is 0. There it is. When temperature is equal to 0, The model predicts the heating cost of 100, and the y-intercept value is right there. During the months when the temperature is 32 degrees, which is freezing, so it's Fahrenheit, would you expect the cost predictions based on the model to be accurate, too low or too high? So 32 degrees, and it's using Fahrenheit the whole time, is over here. That's a tricky spot. I don't like that they did 32. 30, it does look too, well, be careful. So the model is the line. So at 32, the model looks to be about what, Jesse? The model is the line. So the model is predicting what? Oh, you read that? Yeah, maybe. So the model is the line, and the line has been set to 0. So it looks like the model is predicting too high. It's kind of close-ish. Would you expect the cost predictions based on the model to be? Yeah. So too high because the residual is negative. That's true. And that's what we see right here. The residuals are negative around this point. So negative residuals indicate too high of a model, that the actual is lower than the predicted. What heating cost does the model predict for a month of 10 degrees? So we need to go up here to the equation and simply do what? Plug in 10 degrees right here. So we're just going to plug 10 right there, and we go 10 times 1.81, 100 minus, and there it is. There's the predicted heating cost. During one of these months on which the model is based, the average temperature of 10 degrees, what were the actual costs for this month? Ooh. So I think they're trying to be kind of nice right here. They're being nice by doing this. What are they showing you? So there it is right there. What do you know? So the model gives the actual. And we predicted 81.9 or so, 81.9. So what we would know right here. So do you know the answer, Jesse? Because you can see the residual is E equal to -5. The predicted is equal to 81.9. So what does that mean? So the predicted is 81.9. The residual, which is more of this right here, that's the residual. And the actual is where? 76.9, exactly. It's 5 lower than the predicted. Remember, the model is set to 0 right now, and the actual is 5 lower than the model. What would you do if your dot is... it should be... I think they try to make it nice. They might give a little leeway on this one. We could check to see the leeway on this problem. I'd like it if they need to put it exactly on it, or they need to give a little leeway. Do you think the homeowner should use this model? No, because it's very curved. Would this model be more successful if... no, it's going to be the same. Units not changed. No, because units... No. No, because units do not influence the accuracy of a regression. No, because in regression, we're basically doing correlation. I'm pretty sure they're saying no because of the curved pattern. What did they not like? What did they not like? Didn't think that one. Where did we think we might have done wrong? What did I do, Jesse? Oh, is it this one? Is this where they're saying it's accurate? No. What have we done, Jesse? Did we do a wrong calculation? I think we could have very much done a wrong calculation, it looks like. Yeah, because everything here is right. Is this one the one? Round to the nearest cent. Okay, that was right. Ooh, it's this one. Jesse, do you see it? This is where you email Brian. Do you see it? This is where you could email me and be like, hey, so about that question. Nearest dollar. So I think we had everything correct. I was like, I don't see what we got wrong. Yeah, I hate when they do that. It accepts $76. So there's a huge leeway in this question. It's got like plus or minus $1. Does it plus or minus $2? Good. I was about to freak out if it had plus or minus $2. But the real answer right here was, I think, 76.9. It rounds to 77, but they give plus or minus $1 on the answer. So that was the only thing we missed right there. But once again, we really didn't miss it. It was just, it said round to the nearest dollar, and we gave it too many decimals. That's one of the few things I really don't like about my Pearson. Once again, always email me if you get stuff like that wrong. So we did get 100. It was just that we were too exact in our answers. We were too good for my Pearson. Does that make sense, Jesse, on how to do this one? Really good job working ahead on these and getting the problems done, understanding what residuals are. It's how much we miss by. The reason they shouldn't use this model is it has a problem with QQ straight enough. The straight enough condition is not met. So big stuff right there. Well, we'll be back next time. Bye for now, everyone. Bye.